Good morning, afternoon, everybody. Thank you for joining today's training session on the basics of visualizing ocean models with Tecplot 360. This will be a great way to get started using Tecplot 360 for your own work with ocean simulation data. My name is Jared McGarry. I'm one of the account managers here at Tecplot, but I started with Tecplot as part of the technical support team, so I've had some experience working with many of our customers. If you have questions after the webinar, you can reach out to us at support@tecplot.com. Before we begin the training, I'll say a few words about Tecplot, the company, and Tecplot 360, our flagship software. Tecplot was founded in 1981 by two Boeing aeronautical engineers who originally started writing CFD codes. They realized that they needed a way to visualize their results, so they hired a developer to do that for them, and that developer is still active at Tecplot to this day. That was almost 40 years ago, and we are still going strong with over 47,000 customers worldwide and in multiple industries and disciplines. Tecplot 360 is known as the most complete desktop post-processing solution. It has the ability to render not only beautiful 3D plots, but also quantitative plots with line plotting and 2D plotting, where the real engineering decisions are often made. We are dedicated to saving you time, and we do this in several ways. By first optimizing the way data processing is done in Tecplot 360, and reducing the number of mouse clicks for common workflows, and by automating Tecplot 360 through the use of macros and Python. We are also dedicated to solving the big problems in CFD, one of which is post-processing large heterogeneous datasets. One of the most time-consuming parts of post-processing is loading data off the disk. The image here represents our SZL, or subzone load on demand file format, which helps you by loading less data, waiting until you need to use the data to load it, using less RAM because less data is loaded at a time, and performing workflows faster, saving you additional time in the long run. Tecplot 360 is also a suite of tools, one of which is TecBlock Course, which allows you to analyze ensembles of data. For example, if you're doing design experiments, this tool will help you see the big picture and then filter down to the details as a companion to Tecplot 360, getting to the answers you need faster. Tecplot 360 also has a built-in macro language, but more recently we've included a full-featured Python API, which has opened the doors for more advanced automation and post-processing analysis. All right, and with that, let's get to the training. So for the agenda today, I will be looking at a FVCOM ocean simulation dataset of Boston Bay. I'll start with a quick tour of the graphical user interface. I'll then load in the dataset. Like I said, an FVCOM dataset is what we'll be using, and it's what is in the full release of Tecplot 360, but we also have ROMs and WRF data loaders upon request if those are needed for your work. I'll then show some adjustments to be made in the 3D Cartesian plot type that are useful for datasets of this type. Then show some value blanking to isolate the regions of interest in our dataset. I'll then use some derived objects like slices and isosurfaces to get additional information about the volume dataset that we have. I'll then show some data extraction using the Polyline tool. And then I'll show how to export your results with an image export and an animation export, and then we'll get into the questions that have come up. So if you want to follow along on your own, the FVCOM dataset that I'll be using is found in the Getting Started bundle in the Ocean folder. I will be using the Tecplot 360 April 2020 beta, which you should be able to see from the welcome screen as well. And if you haven't already started with the beta and want to try it yourself, we do appreciate the feedback. Send it to us at 360beta@tecplot.com. All right, so I have a fresh instance of Tecplot 360 just to give a quick tour of the user interface. Up at the top here, we have the menu dropdown, we have the file dropdown menu, and we also have the plot dropdown menu, and the data dropdown menu is what I'll be using a lot of today once we get a data set in here. Just below the menu is the toolbars. We have the file toolbar, we have the view toolbar for manipulating the plot once we have a data set in here, data toolbar for adding specific plot elements to update our plot, and then the insert toolbar for adding text, images, polylines, geometries, and for adding new frames. Below the toolbars, we have the plot sidebar, which will update with the toggles for adding and removing zone layers once we have a data set in here. Just below the plot sidebar, we have the frames sidebar, which gives a list of the frames in our workspace that we're looking at here, which is this gray background. The frames are what we will use to contain the plots that we're creating, and we can have multiple frames per page. And to keep track of the pages that we may want to have, we have the pages sidebar on the right. We'll just be working with one page for this training, but pages work similarly to a PowerPoint presentation with the slides, where you can click back and forth between the layouts and frames you have in a workspace and stay within the same instance of Tecplot 360. Below the pages sidebar, we have the quick macro panel, which we won't be getting into in this training either, but if you want to, you can see the scripting drop-down menu to toggle on and off the quick macro panel. And if you want to try recording macros or Python scripts on your own, you can try from the scripting drop-down menu here as well. So because we won't be using this, I'll click off that for now. And the final sidebar we have here is the probe sidebar, which gives us more detailed information about specific points in our data set. So we can right click either the top toolbar or the sidebars to see a list of which ones have been active if we want to toggle on and off any of them. In the center here, we have the welcome screen. So what we have here is quick links to the to opening new layouts or opening existing layouts we've created and loading data, similar to what we have in the file toolbar or the file drop-down menu, links to recent layouts that we have, links to our documentation that are in the installation. One that I highly recommend is the quick reference guide, which has a lot of keyboard shortcuts that I'll be referring to today, and command line launch options for Tecplot 360. And then in the bottom of the welcome screen, we have contact information for our technical support team. I highly recommend contacting them if you do have any questions while you're using Tecplot 360 to help you with your work. All right, with that, let's bring in the data set. So I could load a data set by clicking here or by using the File drop-down menu, selecting File, Load Data. And I've already navigated to the folder where I want my data set. And I can select the file I want here. It's an FVCOM netCDF format file. The default loader that I have here is all supported files. If I want to, I could select the FVCOM loader to isolate the data set type that I want using this data loader. The all supported files, what this uses is it recognizes the file extension for the file, and it tries to pick the best data loader for that file type. So this is perfectly suitable in this case, so I'll just select open. We'll get this notification about the access being updated, and then we have our data set loaded in here. All we really see is this orange bounding box that indicates that there is a volume data set here. And if I want to, I can toggle on and off this bounding box from the options drop-down menu. Now we really can't see anything, so to add a little character to this, I'm going to toggle on the contour, which prompts Tecplot to toggle on the surfaces for this volume zone. So what we're seeing here is the exterior of the volume data set that we have. So the contour variable that it picked by default is the longitude, which doesn't give us too much useful information. So I'll update that in just a moment. But for now, I'll walk through some of the ways we can manipulate the view of our plot. So the first tool we have selected here is the selector tool. And I can select zones by clicking on them and select other plot elements. The next one over is the adjuster tool, which allows us to do a little more fine tuning of the data once we have it in. We won't really use this until we get to the data extraction with the polyline. So we'll skip that for now. The next tool over is the zoom tool. I can click and drag to zoom into a specific region, and I can control left click to zoom back out. Next tool over is the translate tool, which you can plot back and forth. And then we have a whole host of rotation tools. So we have the standard rotation, rollerball, twist, and then these XYZ axes locked rotations, which can be useful if we want to maintain a certain orientation in our plot. So if I want to, and if I zoom in a little bit, I can click and hold the middle mouse button rather than having to use the magnifier tool. I can click and hold right click to translate, and I can control right click to rotate. And if I zoom in a little bit too much and the rotation, which by default is at the origin of our data set, feels a little clumsy as I'm trying to manipulate the plot, we can reset the center of rotation to where my cursor is aiming by pressing O on the keyboard. And now as I control right click to rotate, we'll be rotating around that point. Now if I'm zoomed in a little too far, I can control click to get out, or I can hit control F to do a view fit of all the surfaces. And for reference, that can be found from the view drop-down menu as well. All right, so let's, before I walk through the different plot style changes we can make, let's look at what the dataset is actually contains. So I can go to Data, Dataset Info to bring up the Dataset Information dialog. And I'll navigate to this first tab here. So these zone and variable info tab shows the zones on the left and the variables on the right. The zones are the different regions or paragraphs of data in our data set. And for this data set, what we have is a set of similar regions in space being plotted over time, or representing different points in time. So as I step through here, the points, elements, and time strand remain the same. The time strand is what Tecplot uses to stitch together these zones to properly create the animation, and in this case, it represents the same point in space. And as I step through here, the solution time updates, which is what Tecplot will be using for the animation to create the proper sequence for the animation, indicating which zone represents the appropriate zone in time. Our variables on the right, we have our X, Y, and Z variables, which is what Tecplot has used for the axis variables. And we also have these longitude and latitude variables, which will come into play a little bit later once we make some other slight changes to the plot. The Dataset tab gives us more information about the data file, the directory it's contained in, and then it gives a breakdown of the total zones, variables, elements, and points for our dataset. So the first thing I want to do is make a couple slight adjustments to the plot so that it becomes easier to work with as we go through the rest of the zone layers and derived objects in the plot sidebar. So the first thing I can do is we've included this ability to add a georeferenced image, which we can add by clicking this Insert Image / Georeferenced Image icon. And what this allows us to do is select a world file that pairs with an image, where the world file provides the coordinates and the proper scaling for the image to be placed in our data set. So if I press open, Tecplot just needs to bring in the file, and the image is actually brought in here, but we're not able to see it, and that's because the axis variables that have been assigned by default don't match the coordinates that have been provided in the world file. So we're using X, Y, and Z. If I go to plot, assign X, Y, and Z, X, Y, and Z are the variables that have been chosen by default, but what the world file really needs is the longitude and latitude variables. So I'm going to select longitude and latitude, update the plot here. We'll get this notification that the aspect ratio has been adjusted because of the change in the axis variables. And now we'll get this image that surrounds our data set, giving us a little more context for what we're looking at in this simulation. Now, as we updated that, we have these really high peaks with the Z-axis in our data set. So we might want to change that too, so it's less distracting and we get to see a little more clearly what's happening in those other regions. So to do that, we can go to Plot, Axis, and we have this option to scale down our Z size factor. So I can click one by one, or I can assign it to a set value and just hit Update. And that way, we can see a little more clearly the plot, and it looks a little less obnoxious. So we'll jump over to the middle of the plot sidebar for now, and I'll be referencing this as we make additional plot style changes. But we have this this play button and these step through buttons, which allow us to animate these zones through time. And as I do this, because this ocean simulation dataset actually has some tide changes, we're seeing the surface of the water dip below where the georeferenced image has been placed. So to account for that, what we can do is we can double click the georeferenced image and change the Z position just a little bit so we can still see it clearly, but that way it does not obscure the volume data set as we're animating through. So now as I animate through time, we'll still see a little bit of the ebb and flow, but the georeferenced image won't be obscuring the surface of the water. And that way, once we add more plot elements and plot more interesting variables, we'll be able to see it clearly. The last change that I want to make before I start walking through the plot sidebar here is to use this capability called value blanking. And if I go to plot, blanking, value blanking, what this allows me to do is I can blank or hide the regions of the plot where we have this variable wet nodes, where it's less than or equal to 0. And what this will do is it will obscure, or it'll hide the regions of our plot that don't actually touch the water, or that aren't actually part of the ocean simulation that we might be interested in. In this way, we clear away even more of those peaks, and we'll be able to see the surface of the water a little more clearly and isolate to a region of interest that we want. All right, so let's walk through some of the options we have in the plot sidebar. The first few options we have here are the snap to orientation views. So what this allows us to do is to make quick adjustments to the plot view for certain perspectives that we may want to either come back to or adjust to. So for now, I'm going to use the YX orientation view, so we get this nice top-down view of the ocean surface. Just below the orientation views, we have all these zone layer toggles. So what these are global on-off switches for these zone layers for all the zones. In this case, we're only really seeing one zone at a time because of the transient animation that we have set up. But if I toggle on the mesh, we'll get to see the mesh or grid for the surface here. And if I want to make changes to it and fine tune the mesh, I can double click the surface and I'll navigate to the mesh tab. And if I want to, I could change the mesh color by right clicking here. Or I could do the same thing by right-clicking the actual surface and update and adjust the mesh to an aesthetic that I want. The next toggle down is the contour, which I had already toggled on. So I'm gonna turn off the mesh just for now so I can see it a little more clearly. But the longitude isn't very interesting for what we want to. Or compared to some of the other variables in this data set. So what I may want to do is update that by clicking the Contour Details button here to bring up the Contour and Multicoloring Details dialog. And from the top drop down here, what I can do is change from longitude to something more interesting like the salinity. And then the plot will update and we can see a little bit more clearly or something a little more interesting. So TecPlot will try to assign the contour levels based on the variable range that we have. And if we want to, we could add new contour levels at specific values by entering them here and selecting add level, or we can do an entire reset by going to set levels and define a minimum and a maximum and a specified distribution. In this case, I'll just specify a number of levels and we'll hit OK. And then our plot will automatically update with these new contour levels. Below this, I can make adjustments to the color map that we've selected by default, or I can click this drop down to see all of the other color maps available to us. And we actually have a host of CM Ocean color maps that are really useful for data sets of this type. So I can select the Haline color map to match the salinity that we're looking at. And if we wanted to bring in our own color maps or export the ones we've created here, we can click this gear icon to do that. There's a lot of other options for fine-tuning our color map if we want that I won't get into for this training, but what I will show next is the contour legend and what we can do with that. So the first thing we may want to do is, because we're adding all these contour levels, the legend keeps getting taller and taller. So we can toggle on resize automatically to scale that down a little bit. And as I zoom out and I want to get a full or a better picture of the surface, our contour legend now is a little more difficult to see because of the georeferenced image behind it. So what I can do is I can go to legend box, toggle on fill, so we can see a little more clearly. And I can also do something like size down the font. So now the legend takes up even less space and we have more room for the simulation. All right, the next toggle down is the shade, which was toggled on with the contour when TecPlot turned on the rest of the surfaces. And what the shade is just showing with a single color the surface of the volume data that we're looking at here. So that isn't particularly useful for the simulation, for this plot. So I'll toggle off the shade and just keep the contour in this case. The next zone layer down is the vector. And when I toggle on vectors, I get prompted to provide the vector variables from the variables in our data set. So we have U, V, and we actually have a WW variable that we'll use for the Z component of the plot. So now we get a vector plot showing the flow characteristics on the surface. So there's a couple things we can do to tidy up this plot a little bit and give us a better perspective on what the flow may look like in all of the regions. The first thing we may want to do is, because we're in a 3D Cartesian plot type, but we're viewing in this XY orientation view, the Z component or the W vector variable causes some of the vectors to point up or down into the surface. And if we want to just isolate to the UV components of our vector variables, what we can do is go to Zone Style, go to the Vector tab, and use this toggle called Vector Tangents. And what this will do is it will update some of these. So now we're having the vectors plotted tangent to the surface that they're seated upon. So now we're only seeing the UV components in this view. The next thing we may want to do is use this ability that we've added with the 2020 beta and what will be in the official 2020 release, which is using even vector spacing. So if I zoom in a little bit and I toggle on the mesh, by default, the vectors are being seeded at the nodes. And what even vector spacing does is, based on the spacing criteria provided, is it will skip seeding some of these vectors at some of the nodes to make a more clean vector plot. So let me zoom out a little bit and do reset spacing, and some of those vectors will get removed. And if I toggle off the mesh, now we'll see a more even spacing of the vectors, hence the name, across the plot. So we're getting less clutter in the more precise regions of our grid. And lastly, what we could do is we could change the vector length to, rather than being sized by the grid, we can change it to a uniform vector length and maybe size that down a little bit. So now we get a clear picture of what the flow looks like in all regions of our plot. The last two toggles we won't really be using for this plot, but what the edge shows is the boundaries of our zone, and what the scatter shows is the location of the nodes. So we don't really need to track the nodes over time. We're more interested in what the flow characteristics might be doing. So leaving the vectors on is more useful for us. So we'll keep those toggles off for now. All right. Below these zone layers, I'll get into showing some of the derived objects in just a moment. But what the zone layers allow us to do is give us a big picture or a bigger picture to explore our data set. But if we want to get more detailed information about specific points in our data set, we can use the probe tool. So we have this probe sidebar here where we can select the probe tool, or we can select it from the data toolbar up here. If I click this, our cursor changes to a crosshair. And if I click, it'll update the probe sidebar with more detailed information about the variables at that point. So let me zoom in again, and I'll toggle on the mesh so we can see how the probing actually works for this. So as I probe in a cell, the first tab shows us the values at that specific point. The second tab over, cell center values, gives us the interpolated values from the node. So because this data set has the variable saved at the node, the cell centers probing will show us the same values that are being interpolated from the node there. If we want to get the exact values at the node, we can control click to probe, and the probe will snap to the nearest node, and that way we get the precise variable values at that node. The other two tabs, zone and cell info, gives us information about the zone that we're probing. In this case, we're seeing zone 24 because we're on the 24th time step. And then the cell info gives us information about a node if we've probed at the node, in this case, the element or cell that we're probing, and then the bordering nodes. And then the final tab gives us information about the neighboring cells for face neighbor information. All right, so that's a quick tour of how to explore your data set as is. The derived objects, which I'll show now, are things that Tecplot will be creating from your data set rather than just the data set itself. So the first one is the isosurfaces. So I'll click the isosurface details dialog to open up our options for this here. And what the isosurfaces use are the existing contour groups that we've defined. So it defaults to the first contour group, and maybe we don't want to create an isosurface at salinity, but rather than overwriting the existing contour for salinity we have here, because it's useful on the surface, we can change to the second contour group. Click this details button right here to open up the details dialog, and rather than looking at the latitude, which it's selected by default, let's change it to this variable called siglev, which gives us, which is a range from 0 to -1, and gives us information about the from the surface to the seafloor, and it's a clean way to plot the bathymetry of our data set. So I'll keep the remaining defaults for that because we're not interested in changing the color map for that. We just want to change the definition for the isosurface using this contour group. So I'll change the draw isosurfaces at 2 specified values. I'll change this to 0 at the surface and -1 to the seafloor. I'll hit close. And the reason I'm doing this is because as I rotate our plot here, when we have the contour toggled on, let me just make some adjustments here. There we go. With the contour toggled on for the entire zone, it wraps around here and cuts off our view inside the fluid volume a little bit. So we can't see what's happening in there. We're only seeing what's happening on the exterior. So if I toggle off these zone layers, to clean up the plot and instead use the isosurfaces. If I toggle this on here, what this shows is the value at 0 and the value at -1 showing the surface and the seafloor, but we also get a peek into the fluid volume to see what the bathymetry looks like there. And then we can use this for adding additional derived objects like slices and stream traces to get even more information. All right, so as I'm adjusting this, the next thing I want to do is show the slice tool to give even more information about what's happening in the fluid volume. So to use slices, I can select the slice placement tool next to the toggle. My cursor changes to a crosshair, and if I click here, we get a slice drawn through the fluid volume, and now we get to see what the, in this case, the salinity actually looks like at that point in the fluid volume. And to get an even better view, I can snap to this ZY orientation view, and we get a much clearer perspective of what's happening at that point. With the slice placement tool selected, I can also press Y to change the slice orientation to Y, press Z, change it into Z direction, or press A to use an arbitrary slice, which can be useful for datasets of this type because of the orientation of the fluid volume isn't necessarily in straight X, Y, or Z directions. Arbitrary slicing is a great way to cover more ground in more complex geometries. So let me snap back to the ZY orientation view, get a little clearer picture. And maybe instead of looking at the salinity, I want to see a different variable for the slice. So what I can do is I can double click. And from the contour tab here, so if I go back to the definition tab, this allows us to redefine where the slice is. If I'm happy where the slice has been placed, I go to the contour tab. And like the isosurfaces, I can use one of the existing contour groups to redefine what the variable and color map being used to color the slices. And rather than overriding the two previous contour groups, I can select the third contour group, go to the details dialog, and change to something like the temperature. And I can keep the levels as is for now, and maybe I want to change the color map to something a little more distinct from the Halene color map that I have. So I have the CM Ocean thermal color map, which is great for temperature. And this way I can see a little bit more clearly which contour group represents which variable. And as you can see, we have this legend that is created as we're adding more and more contour groups, so we can adjust that here so we can see both a little more clearly. And if I want, I can double click the legend to snap to the contour legend tab for this contour group. I can do a quick resize. Didn't necessarily need in that case, but I can resize the font, and then I can add a fill for the legend, so it's clearly seen. All right. So the unfortunate thing about the, here, let me open up the contour details again so we can see this. Because of where I placed the slice, we actually don't get too much variability in the temperature based on the contour levels that we have here. So like I was said earlier, Tecplot does its best job to pick the contour levels based on the min and max of the contour variable selected, but the global range for the variable in our dataset might be a bit too vast compared to the local range for what we want at this slice. So we could try and guess and check what levels might be useful at these points. But to make it a little bit easier, we can use this Add Contour Level tool up at the top in the data toolbar. So if I select this, everywhere I click, we get a contour level added along the slice, and it'll update the contour levels for the contour group. So anywhere there's regions where we're not getting as much information, we can add more levels and update this here. And the nice thing about toggling on that resize automatically for the contour legend is it's updating as I'm adding more and more levels, so it doesn't keep the legend getting taller and taller. All right. So the last derived object we can show is the stream trace tool. So the stream traces use the vector variables that we had defined earlier. And if I want to, I can click this add a single or a rake of stream traces. So let me just rotate the plot so we'll get a little more perspective. I can click to place a single stream trace, or I can click and drag to place a rake of stream traces, the default of which is 10. And so I can see some of this right here, but because the slice and the isosurface are obscuring our view a little bit, it's hard to see the remainder of the stream traces. So what I can do is I can double click the isosurface and toggle on translucency, so we can see the path of the stream traces a little bit better and see the flow and where they originated. I can also do the same thing by right-clicking the isosurface and make some additional adjustments if I want to increase or decrease the translucency. All right, so as I'm adding more and more derived objects and my plot's getting a little more complex, it could feel a little bit cluttered. So maybe instead of adding all these plot styles and showing all these variables in one frame, I could use multiple frames to convey multiple portions of information in our data set. So a quick way to, rather than, normally I could just create and draw a new frame from here, but instead of having to start from scratch, what I can do is I can select the boundary of our frame here. I can right click and select copy and then hit Control V to paste. And if I scoot this frame over just a little bit, we can see we now have should have a duplicate frame over top of the other one. Hold on. Let me do a Control V again. There we go. Hold on. Let me try and tile these frames so I can see them overlaid on top of each other. Okay. Let me adjust this here. So one way you can do it is you can copy the frames, or what we could also do is save the plot style that we have for this frame. So I can go to Frame, Save Frame Style, and I'll just call this style1.sty. I can draw a new frame by clicking and dragging. And then rather than resetting everything, I just load this frame, that same frame style, back into here. There we go. Now we get these duplicates here, and I can tile these one on top of the other. There we go. All right. So now for one frame, I could isolate to just showing the temperature. So if I want, I could go to that same ZY orientation, toggle off those stream traces, keep the isosurfaces so we can see the bathymetry a little bit, and adjust the plot view here. And maybe just delete altogether the salinity legend that we have here. So we're just looking at the temperature in this one view. And then for this view, maybe instead of showing the derived objects, I want to show the contour surface and that vector plot that I had created initially. So I can go back to the snap to orientation view and adjust it so we can see the entire overhead perspective of our plot. So because this is a transient data set, as I step through here, I want to see the animation changes in one frame, but it isn't updating the other frame. And that's because I just need to instruct TecPlot to link certain aspects of the frame together so that they animate and update at the same time. So to do that, what I'm going to do is go to Frame Linking. And we have a lot of different options that we can link together between these two frames. The one I'm interested in is the solution time. So if I select this and hit Apply Settings to all frames of this group, we'll see this frame slightly update. And as I restart the animation, not only will we see the animation in the top view, we'll see the animation in this slice intersection view as well. So that's a really useful way of showing not just multiple perspectives of our data set, but also showing what the different variables in our data set look like at these different points in time. All right, so I'll stop that animation just for now. And what I want to get into next, that's a quick walkthrough of the plot sidebar to explore our data set. And now I'll get into a little bit of data extraction so we can get even more detailed and isolated information in our data set. So let me zoom in just a little bit. There we go. And what I can do here, let's say I want to not just see the contour of the salinity, but I want to know what the specific salinity values are along a specific path. So to do that, what I can do is select the Polyline tool, and I can click to define the points of our polyline. There we go, hold on. Looks like my polyline is not shown here. Let me just reset this view. There we go. So I can use this to define the path of the polyline. I can make it as complicated as I want. And if I right click, then it'll finish. And if I want to make it a little more pronounced, I can right click to change the line color so there's a little more contrast. If I want to increase the line thickness to make it more visible, I can do that. And if I want to make some additional adjustments, I can use the adjuster tool. So I can select the individual points. Maybe I went out a little too far when drawing the path here, so I can bring that in. And then if I want, I can extend this path out a little bit, and vice versa for this one. And if we're happy with the path of the polyline, I can then left click it, right click, and select extract points. And then we're prompted through this dialog to extract along the path of the geometry, the default of which is 200 points, or we can extract only the points that define the geometry. So each click that I made to create the path. In this case, I'll keep the default and go for 200 points and select extract. And what we'll have from that, if I go to dataset info, is we'll actually see a new extracted point zone. That's an I-ordered zone from 1 to 200 for each of those points that Tecplot extracted along the path. So the next thing I want to do is show the information along the path of this polyline. Unfortunately, for this data set, the variables that we have that are spatial variables are x, y, z, and longitude and latitude. But this polyline doesn't really follow any of those variables cleanly. But what we can do is we can calculate a new variable that is effectively the length or path along the polyline, and we'll plot along that rather than one of our predefined variables. So to calculate a new variable, we'll go to Data, Alter, Specify Equations. And it's a pretty straightforward calculation. We'll just go to I equals I. So this is calculating a new variable for the I index in the data set, or in the zone that I've selected. In this case, I just want to calculate it for that extracted point zone. And if I hit compute, data alteration successful. And if I go to dataset info and go back to extracted points and see this new I variable, we have 1 to 200 for each of the indices or points along that polyline. So now that we have that variable, I can create a new frame. I can select this tool here up at the top for create new frame, or go to frame, create new frame as well. And I can click and drag to create a new frame. And now it's as if we're starting from scratch, where the plot sidebar is blank because it doesn't think there's a data set there. But if we select the plot type and change to XY line, this will instruct the frame to inherit the data set beneath it. In this case, the fluid volume zone, and then the extracted point zone that we just created. So we'll keep the first toggle, x-axis variable versus y-axis variable, for just one zone. In this case, the extracted point zone is all we're interested in. But we're going to change the x-axis variable from x to that newly calculated I variable, which is the path along the polyline, and then change the y-axis to the salinity, and we'll hit OK. And now we get a nice XY line plot showing along the length of the polyline what the behavior of the salinity looks like. So if I wanted to, the useful thing about creating this XY line plot from the extracted point zone is we actually have all the other variables in our data set as well. So if I want to, I can select mapping style, which is similar to the zone style dialog, but not quite. It's got a couple differences. This points to the zones in our data set for the mappings, and we can create a new mapping by selecting create map here. Let's go through the x-axis and change it to I, and instead of salinity, let's look at the temperature along that point, and we'll hit OK. So when I create a new mapping, we don't see the temperature line plot, because if I Control F to view fit, and I'll zoom out just a little bit, it's because the range of our temperature doesn't match the range of our salinity variable, but because they're plotted on the same y-axis, this doesn't match up very well because the values are so different. So what we can do is we can change the axis that one of these is plotted on. So I can navigate over to which y-axis for our temperature mapping and change it to Y2. And then if I do a view fit again, now we'll get the salinity range on the left, the temperature range on the right, and we get to see both line plots on top of each other without having to have too vast a range between them. So now if I want to, I could make changes to the line definition. I could change the line color by right-clicking here. I could also right-click the lines themselves to make adjustments. Let's see here, if I want to change that to orange or something, I could change the line pattern. So we can make a lot of style changes to make them more distinct. As it is now, we can see the axes, but it doesn't give us an indication of what each line represents. So for that, we can go to Plot, Line Legend, and toggle on Show Line Legend. And right now it just says map 0 and map 1, which is a good start, indicating which line represents which mapping. But if we go back to the Definitions tab, we can also change the map name. So if I double click here, I could change it to salinity. Or I could right click and use one of these dynamic text options. So if I double click dependent variable name, dependent variable number, that'll update it with the, that'll update the map name here and then also on the line legend showing the salinity value. So maybe instead of showing the number, I just want to show the dynamic text name, and I can do the same thing here with that. There we go. So using the dynamic text options for the mapping names can be really useful for, especially when we create lots of different mappings or we're making adjustments to quickly update the plot. All right, so now if we're happy with the way our plot looks and we want to share our work with our colleagues or just show it to them if they haven't started using TecPlot yet, or if we want to use it in a paper or a presentation, we can export our plot. So for that, we can go to File, Export. And from the export dialog, we can see the multiple different raster and vector image export options, depending on what we want to use it for. We can change the region that we're exporting in. Defaults to all frames, but if we want to isolate frame by frame, we can do that as well, just exporting the active frame. And then the work area exports everything that's over the gray workspace at the bottom here. You can just barely see it in between the gaps in these two frames. In this case, using the all frames option is great. We can redefine the width if we want, and we can toggle on and off anti-aliasing if we want a more clean export. So if I select OK here, let's just call this export 1, and I'll hit save. And that way we'll have an image that we can share with our colleagues if they haven't started using TecPlot yet. So that's export option number 1. The other export option that we can use for this data set is using the animation export. So if I hit play here, we're showing the animation on screen. And if I want to make adjustments to the animation, start and end time, or if I want to introduce a time skip, we can click this time animation details button, make adjustments to that here, change the animation direction if we want. And if we click this film strip icon, we have the option to export our animation to a video file shown on top, or a sequence of images if we want to do that as well. Similar choices for the regions we want to export in, the width, anti-aliasing. So there's a lot of flexibility in the animation exports you can create. So we can go into each individual dialog. So if I go to this bottom frame here and go to the Animate tab of the Slice Details dialog, or I can see the Animate tab of the Isosurface Details dialog. But for full breakdown of the animation options available to you, you can go to Animate and see which animations are possible based on the data type and or the derived objects you've created in your frame. All right, and that concludes what I wanted to demonstrate today in TecPlot 360. So I'll switch back over to the slides here, and then I'll get into some of the questions. Before I get into the questions, just a heads up for the next Getting Started with TecPlot 360 webinar we will be doing. Will be on July 16th, starting at 11 a.m. Pacific. And I will be using a converged dataset to show an internal combustion engine simulation. So different data type than what we've presented with in the past, but I'll be covering a lot of the basics for TecPlot 360 in general, but also some specific tips and tricks for data sets of that type. So if you want to, you can register at our on our website at support/TecPlot-training if you want to sign up for that right now. All right, and just as a reminder, if you want to see the recorded webinars or sign up for the trainings, you can go to support/techplot-training. Like I said, you can see a host of tutorial videos that we've created that are 3 to 5 minutes long and cover specific topics by going to tecplot.com/videos. And like I said at the beginning, if you have questions following this, or you just have any questions while you're using TecPlot, go to support@tecplot.com or support-eu@tecplot.com if you're in Europe, and we'll be happy to help you with any questions that do come up. All right, so just give me a moment and I will bring up some of the questions here. I'll have my colleague, Scott Fowler, who's also our product manager, help me field some of the questions as I transition over to that. So just give me a moment.
Yeah, Jared, thanks for the presentation. There are quite a few questions that came in during the webinar. I've answered a number of them in the questions pane, but I'll just go over them via audio while Jared's catching up. So Jared brought in a georeferenced image. Question that come in the netCDF file. No, it was not in the netCDF file. We used the tool QGIS or QGIS to create that image, and the steps are fairly straightforward. If you're not familiar with QGIS, it's free open source tool. If you need help creating images using that tool, our support staff does have some experience with it. We're not geoscience experts here at TecPlot, but we do handle some of these file formats now. Like Jared said, FVCOM, ROMs, WARF. FVCOM is on by default in our installation. ROMs and WARF loaders are in the installation, but they're not on by default. So if you do use those formats, please contact us and let us know. Those file loaders are still form, so there may be some bugs in there, but we're trying to iron those out before we turn them on by default. Can you import shape files? So the answer is yes, but we don't have direct support for it. We do have a Python script available on TecPlot's GitHub page, which can convert shape files to TecPlot binary PLT format, and then you can import it there. In the question panel, I included a couple of links to a video that Jared did, the Python script. We have one that's asking about Schlieren images. It's frequently used for high-speed aircraft. We can't do Schlieren, but we can do shadow graph. So if that's a good alternative for you, we have a couple of links in the question panel about that. And then the last one that I've directly answered is, can you use the polyline to do a transect and make a vertical plot along that line? Again, this is not built into the product directly, but we have written a Python script that does this. It is, the Python script requires FVCOM data, so it requires that siglev variable that Jared mentioned earlier in the webinar. So if you do have FVCOM data, you can use this vertical transect Python script, and there's a nice video again on how that's used. So Jared, do you want to jump in on any of the questions? It looks like a number of new ones are coming in.
Yeah, so the next one down that I'm seeing, how do you change the x-axis to distance instead of points? So I'm assuming that's referring to the XY line plot. So for that, you'd need a variable that does represent the distance. In this case, the I variable that I selected, like you saw, is just the points along the polyline. You should be able to, from the integration tool, you should be able to calculate the length along the polyline and then create a variable from that. I don't know, Scott, do you have any other ideas for either bringing in a distance variable or calculating a new distance variable to use as the x-axis?
I think the best way to do to compute distance along that line is going to be using our Python API, and at each point you're able to get the x and y values and compute distance using the Pythagorean distance. I don't think that analyze option is going to work that you showed there. Okay. So, and we can certainly help with authoring of a Python script if you need distance. The vertical transect tool that that I mentioned earlier does compute distance along the line for you, so you could take a look at that.
Next, I'm seeing how can you show real time as you move through images on the plot? So I'm thinking that's referring to as we're animating what the time step might be. So one way we could do that is I can create a text box, click to place it, and then we have this option to use dynamic text, and I should be able to refer to the oops, not solution time, solution. Okay, let me, as the plot's updating, solution. Let me turn off redraw as I'm updating this. Oops. Hold on. There we go. Got a little weird artifact there. But we can use dynamic text on the plot itself to refer to one of the aspects of our data set. And so as I step through time here, that should update and show the solution time on the frame itself. All right, the next one, how does Tecplot deal with large movie exports? And saying you've had issues with that in the past. So I guess one thing to keep in mind while doing some of the animation exports is anti-aliasing can really slow down some of the exports, especially for larger and larger data sets. So either toning down the super sample factor on that can correct it, or you can also try exporting as a sequence of images and then stitching those images together, especially if you have a large number of time steps. That's one way you can get around some of the memory issues that can crop up, especially for bigger data sets. Scott, do you have any other suggestions?
Yeah, and another thing that I'll point out is that as you animate through time or as you progress through time, Tecplot will continue to load data, and so you'll see the amount of RAM being used increase. But Tecplot also has an intelligent strategy for offloading RAM. So if you do see the memory requirement continue to grow, don't fear, because we will offload data as it's no longer used. So we offload the oldest data first. We have what we call a cell aging algorithm in there. The other thing to note is that if you have cell-centered data in your data set, a lot of Tecplot's algorithms require that data be interpolated out to the nodes. This is important because we will compute the nodal values, and then we store that in a temporary location so we don't have to recompute it later. So we've had some people run out of disk space because they have very large simulations, and we're doing a lot of computation. So if you're able to make sure that your temporary directory has plenty of disk space, please do that.
So your question, will the polyline data change with the time step selected, or will a new polyline be required for different solution times? This is a good question. So the default extraction option I use is just extracting for that specific time step. We do have an option if we select the polyline and go to data, extract, and extract polyline over time. This allows us to do a extraction for each time step, and then we can create a plot from that. The type of the plot type you'll want to use to keep track of that is different than what I was showing here with the XY line plot type. You'll want to use a 2D Cartesian plot type and with a couple other steps involved, but you can show a similar plot style for the variable across that line over time when you do that type of extraction. So there are two different ways we can do the polyline extraction. Actually, there's really three different ways we can do it. We can draw the polyline here and extract the points. We can extract over time, or we can use this data extract precise line where we can specify exact start and end points for our polyline along a surface or even through a volume if we want. So there's quite a few different options for data extraction.
I'll take the next one here, Jared. Is the new beta version available to download 2D variables from FVCOM, or more precisely, interested in the depth averaged velocity components? The answer is currently not, but we have experimented with the loader to do that. So if you really need this, please contact me or Jared directly, and we can work with you to try to update our loader. We've had some, I know that our development staff has loaded that data in before, but we weren't really happy with how it presented in Tecplot, so we haven't done it yet. But yes, we do have the knowledge to do it. It's just not delivered yet. And then there was another one. Can I use an imported Google Earth image as a georeferenced image? The answer is maybe. Certainly, Tecplot can import any image into the plot. So it's one of, do you have an accompanying world file? Or in this case, Jared showed a PGW file. So that's a PNG world file. So you need that world file associated with it, which defines the region of that image. If you don't have a world file, you can just bring it in as an image and then pan and zoom that image to get it to line up with your data.
Next question I see is, can the polyline be used to show transient data where the x-axis is the polyline curvilinear axis and the y-axis is the variable that changes in time? Well, there's not using a polyline, but there is a way to show at a specific point the behavior of the variable over time. And with that, you can go to Tools, Probe to create time series plot. And at the area that I'm probing at, Tecplot's going through and actually extracting at that specific point a new region of data that can be used to show an XY line plot of that variable over time. So and these will automatically be linked. So if I step through time here, we'll see what the behavior of the salinity looks like at that point, and then we get this bar indicating what the current time step is for that point. So not exactly using the same polyline tool, but there is another way to extract information over time.
Yeah, and I think perhaps Jared, he may also be referencing extract a polyline through time. So if you go to data extract, once that operation is done.
Yeah, so this goes back to that, or similar to that earlier question where data extract polyline over time. You can do, if you want to extract the polyline, you could do something like that.
Right, and then there's the follow-on question: is it possible to animate the XY line along with the other frames in your demo? And I think that comes back to XY line plots don't have the capability of animating through time like the 2D and 3D plots. So you could represent a line plot using our 2D plot type. You don't have the multiple y-axes, but you can simulate a line plot using the 2D plot type. So yes, it's possible, but no, it's not quite as easy as we'd like it to be at the moment. And then final question, can you show solution time in days, such as year, month, day, hour? Yes and no. Again, not built into the product directly. So Tecplot just grabs the solution time that comes out of the data files, and that's what we present. But again, with our Python API, it is possible to create an attribute of the plot to show the solution time in that format. So I'm not sure we have a video or a tutorial available on our website, but that's something that we could do. And if you want to contact our support staff directly, we can certainly help you with that.
It looks like those are all the questions that have come in so far. Again, I'll circle back to this. If you have questions following this, email us at support@tecplot.com. So thanks everyone for tuning in. I hope you have a great rest of the day. Take care.